this project, we will build a complete to-do app that uses React for the front end and .NET 5 for the back end. This is not a tutorial, so I expect that you have some basic knowledge about .NET and React, and you would like to move ahead and see how to apply this knowledge in building an app that is very close to real-world applications. So you will learn how to create a .NET backend from scratch, how to set up a proper solution structure, create repository, service, and API layers, how to set up entity framework and migrations, and then how to create unit tests. Then you will learn how to create a React app and set up Redux from scratch, create a to-do feature in this app. By the end of this, you will have an end-to-end working app, and you will have an understanding of how things flow front end to back end. There are a few prerequisites. You need to make sure you have them before you start the project. For the backend, I'm going to use .NET 5, but I think you can still follow along if you have .NET Core. For the front end, you will need to have Node installed on your machine. For the database, and to make it easy to follow along, I'm going to use SQLite. You can easily download it from here. Now, if you have macOS, then it comes already pre-installed. For the code editor, I'm going to use VS Code, so you can use this one if you wanted to follow along and use the same extensions that I do. So I created this new repo fullstack-.net-react for our front end and back end, and I'm going to go ahead and create a subfolder called backend to host all of our backend code. And then I'm going to create another folder called front end once we get to the front end part. Inside the backend folder, I'm going to start setting up our solution structure by creating a solution file. Then I'm going to create the web API project. Then a class library for the business logic. Now we need to add references from the API to the core and data, and from core to data. .NET 5 by default uses HTTPS, then you need to trust the development certificates. Now we can build our solution. Okay, now our API is running on HTTPS localhost. So the default template for web API comes with this dummy controller called weather forecast. You can see it here in the VS Code. And so if we curl this endpoint, we should get the dummy data. Now to run migrations, we'll need to have the entity framework command line tool installed. And as you can see, I already have it installed. If you don't, then it will install it. Next, we need to install some NuGet packages in our data project. And I'm going to use SQLite as a database for this project, so we need also the SQLite NuGet package. Okay, now we're ready to create our entities. So in the data project, I'm going to create a new folder called entities. Then I'm going to create a new file called to-do. In here, I'm going to add some properties for our to-do entity. Now we need the DB context, so I'm going to create a new class. Next, we need a context factory. Okay, now we can create our initial migration. Now we can update our database. Okay, so this created a new folder here called migrations with the initial migration, and also it created a new SQLite database. To keep our business logic isolated from the data source, we're going to create a simple data access layer. So in the data project, I'm going to create a new folder called interfaces. And inside this folder, I'm going to create a new interface called iTodo repository. The iTodo repository will define the basic CRUD operations over the to-do entity. To implement this interface, I'm going to create a new class called To-Do repository. So in the data project, I'm going to create a new folder called repositories. And in here, I'm going to create a new class called To-Do repository. This class will use the To-Do context to interact with the database and implement all the operations. When adding an entity, I'm just going to check whether it has a valid ID. Otherwise, I'm going to give it a new one. Find async will just forward the operation to the To-Do context. The get method will just return to-dos as iQueryable. In remove to-do, I'm going to check whether to-do exists before removing it. When updating a to-do, I'm going to check whether it is already tracked by the local context and then update it. Alright, so now we have our data access layer ready. Now our demo application doesn't really have any business logic to it, but I created this to establish the pattern of separating the business logic from the data source. So in the core project, I'm going to create a new folder called models. And in here, I'm going to add our application modules. In this demo application, we only have one module, which is the to-do module. The to-do module will just copy the properties that the to-do entity has. In the core project, I'm going to create another folder called interfaces. And in here, I'm going to define our to-do service interface. The to-do service will define basic CRUD operations over the to-do module. Now to implement this interface, I'm going to create a class called to-do service. So in the core project, I'm going to create another folder called services. And in here, I'm going to create a new class called to-do service. Now to implement this class, I'm going to use the to-do repository. And we will need a constructor so that the IOC container can inject this dependency at runtime. We've forgotten to do the same for the to-do repository, so let's do this now. Now, as I said, our demo application doesn't really have that much business logic to it. So most of the logic here is just gonna be mapping from the to-do module to the to-do entity and then map back when we get the result back from the repository. Here I'm gonna use simple mapping, but we could have also used some tools like AutoMapper. In the delete to-do, I'm just gonna forward the operation to the repo. In the get to-do, I'm gonna check whether the to-do exists and return it. Otherwise, I'm gonna return null. In the get to-dos, I'm going to use the iQueryable returned from the repository to get all the to-dos from the table and then project them to to-do modules. In .NET 5, to have the async version of the to-list, you will need to have this namespace, Microsoft.Entity Framework Core. And for this, you have to add the Entity Framework Core package to this project. For the update to do, I'm just going to map from the model to the entity and send it to the repo and then back from the entity to the model. And now we have our to-do service ready and we can use it in the to-do API. In this demo project, we will need one endpoint, which is the to-do endpoint. For this, I'm going to create a controller called to-do controller. So here in the API project and in the controllers folder, I'm going to create a class and call it to-do controller. Now to designate this class as an API controller, we need to put the API controller attribute, and we also need to inherit from controller base. Now for this controller, we will need one dependency, which is our to-do service. The first action I'm going to implement in this controller is the one that corresponds to getting a single to-do. Now this action needs to be an HTTP GET, and it's going to return a to-do if it is found, and it's going to return not found result if the to-do cannot be found. Okay, so the next action I'm going to create is the one that gets a list of to-dos. Next, I'm going to create an action that corresponds to the HTTP method post, which will create a new to-do. But before that, and to prevent overposting, I'm going to create a model for the request body of this method. So in the API project, I'm going to create a new folder called models. And in there, I'm going to create a new class called createToDoModel. In here, I'm going to have only two properties, which are the only two ones that are allowed in a post request. Description and is complete. We will not allow the user to choose the ID. And now we can create our action method. Now I'm going to create an action for the HTTP method put, which will update a to-do. And for that, I'm also going to create an update to-do model, just like I did with the create to-do model. So here in the models folder, I'm going to create a new class called update to-do model. Now we can create the action method. So in this method, I'm going to first check whether this ID matches the ID that is sent in the request body. If not, then it is a bad request. Then I'm going to check whether the to-do exists, and if it does not exist, then I'm going to return a not found result. Otherwise, I'm going to update the to-do and send a no content response. Now we will need to designate this method with the HTTP put attribute and also the response types it produces. The last action method we need is the one to delete the to-do. This one will receive a to-do ID, and if it is not found, then it will return no not found response. Otherwise, it will delete the to-do and return a no content response. Now we will need to designate this action method with the HTTP delete attribute and also state the response types it produces. And by this, we are done with the to-do controller. One package we need to install into the API project is the Entity Framework Core SQLite package. Now in the startup file of the API project, we will need to register our dependencies. One more thing we need to do, which is to enable cores, otherwise the front-end application that we will create won't be able to call this API. For now, to make things easier, I'm going to allow any origin, but in production you would need to change this setting. Then in the configure method, we will need to use the cores policy. I've told .NET Core to pick up the connection string for the SQLite database from the configuration, and that's why we would need to add the connection string config to the app settings file. So because we are in development mode, I have put the connection string setting in the app settings.development.json file, and I've pointed this to the database we've already created in the data project. Now, before we try out our API with Postman, I noticed that we had a typo in the to-do controller's route here. So we need to add a square bracket. Now, another thing in the app settings.json, I noticed that we have forgotten to say data source equals the path of the database. All right, so with that in place, now we can start our app. Okay, so now our application is started and we can see the Swagger documentation of our API. I'm going to be using a VS Code extension called SQLite to access our database. So to open the database, we need to say Command-Shift-P and then open database and then choose the todos.db. Okay, now let's use Postman to test our API. I'm going to issue a post request against the to-do endpoint with the following to-do. So we can see the response is 201 created, and we've gotten the new to-do with an ID. Now let's check in the database and verify that this to-do got created. So in VS Code, I'm going to say Command-Shift-P and new query. Command-Shift-P, run query. And here we can verify that the to-do got created. Let's try another one. Also created. And also created in the database. Now let's copy this ID and try the get to do. When we execute this, we get a 200 response code with the to do. Now let's try the delete, and we get a 204 no content, which means the delete operation was successful. Now let's check in the database, and the to do got deleted. Now let's try to get all the to dos in the database, and we have only one to do. Let's try to update this one. And we get a 204 no content, which means the update was successful. Let's check in the database. And it seems we have updated our to-do. Okay, so as a smoke test from Postman, we can see that our to-do controller is working as expected. I'm going to add some unit tests, which are by no means comprehensive, but again, just to establish a pattern and to give you a complete boilerplate you can use in your projects. But first, we need to do some setup. So in the terminal, we will need to add a new xUnit project. Then we will need to add this project to the solution, and then add the references to the other 3 projects. Now we need to add some NuGet packages. I'm going to be using a substitute for mocking dependencies in unit tests, so we need to add this NuGet package. Okay, now we can start writing our tests. So in the test project, I'm going to add a folder called data to add tests for classes in the data project. I'm going to add another folder called core for testing classes in the core project. And finally, another folder called API for testing classes in the API project. Okay, so inside the data folder, I'm going to create a class called to-do repository tests. Now for a unit test, I'm going to be using the entity framework in-memory data provider. So I'm going to add a test that will add a to-do to the database and verify that it got persisted. So usually when we design tests, we design them to fail first to make sure that they are working properly, and then we design them to pass. So I'm going to say here not equal instead of equal, and then now let's try to run this test. Okay, now the test failed. Expected not equal, but it was essentially equal. Now let's try it again. Now we have a passing test. Okay, so I'm going to add another test to verify that we can update to do. So let's design this to fail first. So I'm going to say not equal, and then let's run. Okay, now we have a passing test. Okay, so these are sample tests for the to-do repository, and now let's move to the to-do service. So in the core folder here, I'm going to be creating a new class called to-do service tests to add our unit test for the to-do service. So I'm going to add a test to verify that the create to-do async throws an argument null exception if the to-do model is null. Now let's add a unit test to the get to do to make sure that it maps the properties correctly between the to do entity and the to do model. Okay, so I'm not going to be adding any more tests either here. Let's move to the API and add some unit tests there. So in the API folder, I'm going to create a class called to-do controller tests. Okay, so the first test I'm going to add here is to the get to do action method to make sure that it returns a not found result when the to do is not found. So let's do that. Okay, now let's add another test to the get to do to make sure that it returns an okay result when the to do is found. Okay, that's it for the unit test for the API. You can add more if you like. I'm going to create our React application using the Create React App tool. So in the terminal and inside the root folder, I created another folder called frontend to host all of our frontend code. And in here, I'm going to run Create React App. Once done, we can run our app using npm start. So this has created this template for us. I'm going to go ahead and delete some files which I know I'm not going to use. I'm going to use Materialize CSS for our CSS, so we need to set up Materialize. To do this, we just need to link to the style sheet. So I'm going to copy this, and inside the public folder, in the index.html, I'm going to paste this above the title. One more thing I'm going to use is the icons, and we also need to add a link for them. Now I'm going to install all the packages that I know I'm going to use. So I'm going to start with Redux setup first because it's a bit involved. And once we have the basic boilerplate for Redux, then we can focus on our app. Inside the source folder, I'm going to create another folder called Redux to put all the Redux stuff there. And here I'm going to create a file called store.js and another 3 folders, one for actions, one for reducers, and another one for selectors. In the reducers folder, I'm going to create a file called root reducer. And in here, I'm going to add the basic setup for our reducer. Now in the store file, I'm going to add also the basic setup for the store. Okay, this is everything we need for the store for now. Now in the index.js, we will need to use the provider from React Redux and give it the store. Now for our to-do feature, because we know the backend API, we can start laying out the Redux setup for this. So we can create our actions that calls the API and also create the to-do reducer. Okay, so let's start with the actions first. So in the actions folder, I'm going to create a file called to-do actions. We will have two set of actions, one to update the Redux store and another one to make calls to our API. And because we are using Redux Thunk, then you can make these operations asynchronously and also dispatch other actions. Now we create the action creators that will call the backend API. So here we will need the base URL for our backend API, and it's better to put it in an environment variable. So in the frontend folder, I'm going to add a new file called .env. Another action creator that will call the API to delete a to-do and then dispatch the delete to-do action. Another action creator to call the put endpoint and then dispatch the update to-do action. We need two more, one to get a single to-do and one to get a list of to-dos. Okay, so now that we have our action creators ready, we can move ahead and create our to-do reducer. So in the reducers folder, I'm going to create another file called to-do reducer. The initial state of the to-do reducer will just be an empty array of to-dos. The reducer is a function that takes a state and an action and returns a new state. So what we need to do is to create a function that takes a state and an action, and based on the action type, it will mutate the to-do state. Now we need to add the to-do reducer in the root reducer. You can use selectors if you have a complex state or if you want to use advanced features like memoization. In this case, I'm just going to create a very simple to-do selector, also just to establish the pattern. For the to-do feature, I'm going to create 4 React components. One component is going to be a higher level component that will connect to the Redux store, and other 3 simpler components. In the source folder, I will create another subfolder called features, and within it, I'm going to create a subfolder called to-dos. In the to-do folder, I'm going to create 4 files representing our 4 React components. Now I'm going to start with the higher level component so that we can connect this one to the store and also add some dummy data to see how the to-do list and the to-do item look like. Now in the to-do reducer, I'm going to add some dummy data. Okay, now we can create the to-do list. We need a simple logic here so that if the to-dos array is empty, then we display something like you don't have any to-dos. Otherwise, we map every to-do to a to-do item. Now we can create the to-do item. I'm going to create this to-do item such that when clicked, it will toggle between completed and not completed. Then I'm going to add a button that once clicked, it will delete the to-do. Now in the app, we need to add the to-do page. Now we need to wire up the action. Let's add our to-do form. All right, so now we're ready to fire up the backend and to test the full application. Okay, now we can test the front end and the backend together. So I have started the backend here, and if we query the database, as we can see, there is nothing in the to-dos table. So let's try to create a to-do. Okay, so we can see here that when sending the to-do, we have sent only the description and not the full to-do object. Now we see that we hit our controller in the backend, and our test to-do is created. So now we can create to-dos. Let's try to delete. Let's check in the database. There is nothing again. Now let's try to create another one. Let's check in the database. Yet another one. Now let's try to set this to done. And we can see it is completed. Let's try to set this one also to done. Let's try to delete this. Okay, so now we've fixed all the small bugs and we have our app working end to end.